How you guys doing? So I'm working on a. Uh, I'm using multiple levels of Perlin noise, right? Offset and scaled. Um, it's being filtered. For instance, the outline filter. I can find all the outlines between the two different bands in my banding system. This is traditional Perlin noise. Now I can scale this Perlin noise down or up, and I can offset it from its normal position. Now, you'll probably notice in the background over here this piece of whatever, let's call it terrain for the moment, is actually shifting in real time with this map. This data is being calculated on the fly, like all of it's being generated and calculated every single frame. There's some tweaks keeping the variables alive for memory management, but otherwise it's being calculated every frame. Um, so I can select different layers here. So far it's fixed with 3 different layers. You can see there the layers kind of blending together. Basically it takes the Perlin noise, it divides it by 3.333 down, cuts it to a third more or less, and then adds them all together to come up with this blended map. And you can adjust it and all, and that's fun. But then you come down here and you click band, and it groups it into tenths. Since Perlin noise is a float value from 0 to 1, this takes every 0 to 0.1, 0.1 to 0.2, 0.2 to 0.3, so on and so forth. And it's supposed to group it together. Now, obviously, there are not 10 different colors here, which there actually should be, or at least 9. So something's not quite adding up right, but it's working, so no complaints. So the banding is the one thing, because I wanted to generate this type of terrain. And then the outlining. Now the outlining, this messes it all up over here for my little demo, my terrain. It drops that black layer all the way down. But the purpose for that is to locate cliffs, basically. I have a set of assets down here, various assets, and these are just flat terrain, but somewhere down here are these guys. They are cliff pieces. Now they're very low poly, and this looks a lot like Minecraft, and you could scale it like a Minecraft world where every block was, um, you know, like half a player's height. But if you were to stretch this world out further, the low poly effect would kind of be real bland, but you can use texturing and other things to give it some more detail. But this cliff could be like, 3 people tall or something like that, and the world could be fairly big. But I wrote the algorithm to find basically the outline and to calculate the outline with just the selection, and to band the map into groups with just a selection. You can obviously see the resemblance when it's turned on and off, and then the outline. And all that is being done in real time, every frame. At right now we're at 67 frames a second. As I move that, 22 frames a second while it's updating. But as soon as I stop moving it, jumps back up to 60. It's a little intense. This is using Unity's new systems that are multi-threaded and more lightweight than the old stuff. A lot of fun. A lot of experimental beta branch, but I'm having fun with it, and I enjoyed the technical problems. I have another project I can probably show you if I can pull it up real quick. Um, I don't know if it'll run. I haven't updated it in a minute. I'm not sure if all the code is still updated to the latest beta version that I I have installed. But it should work. It shouldn't have any problems. Hopefully it doesn't take too long to load. So this is my first, the one I'm loading now is the first experiment I ventured into with the new multi-threaded systems and the new Unity systems for improved performance and scale. And what I was trying to do was simulate a solar system in essence, or the like. I spawned multiple sized bodies with various gravity based on their size, and I kind of gave them some initial motion to get them going. And let's just watch. It does still work. That's wonderful. Now I'm running this. This is running at the moment 480 frames a second. That's kind of insane, considering that over. Let me make this a little smaller where you can watch it. So every single object is calculating its position versus every other object every single frame. Now I have basically mass and velocity and position as the three main variables. But all in all, there are 7 mathematical calculations required to figure out the gravitational attraction from one object to another. That doesn't include like memory operations, fetching variables, jumping into functions, things like that. Just the mathematical calculations. It takes 7 different calculations to figure out the attraction from one object to another. And every single frame, it's checking every other object. Now, at the moment, where are my settings for this? Resources, spawner data. We are only spawning 250 objects at the moment. So 250, checking 250. You get the idea. It kind of ramps up rather quickly. And that was at 450 frames a second. So if I kick this up to 1,000, we're going to spawn a full 1,000. Now I'll use this view, kind of back off. Now it's got a little delay. It's spawning 50 at a time, but there's more and more. You can see the sun starting to be pulled by the mass of all the other things. It has more gravity than everything else. It's being calculated versus everything else at the same time as well. And again, 340 frames a second with 1,000 objects being calculated versus 1,000 other objects every single frame. Pretty intense. Now, if I get it up to 5,000 objects, I believe I did the calculation on that, and it was something in the tens of billions of calculations per second to figure out each frame. But one of the fun things I've been having, well, I haven't worked on this in a while, but this was my first, like the very first thing I worked on when I was playing with these new systems that allow you to process this many objects at once so much faster. If I pull up my profiler, debug, no, here. So editor runtime overhead right here is just looking at this data is costing me 5 milliseconds. But I can scroll in here and expand this. This down here, all these are my worker threads. This is taking advantage of my 16, my 8 cores, my 16 threads, and every thread has stuff going on. You can see gravity system calculate attractions is going on right there. It's being burst compiled. That's something that's helping speed everything up. If I pause this real quick, I have a camera system that I programmed being calculated, taking 0.8 seconds, or excuse me, 0.8 milliseconds. An update function taking 0.8 milliseconds. Wait for jobs. Anyway, you can analyze things. You can kind of see what's going on. I have all these jobs down here being worked on. Idle time. All in all, it's fairly performant, and you couldn't do this with Unity before. Major updates, really cool stuff. Anyway, I thought I'd share. I still like watching this every time I spawn it because cool things can happen. It's completely random, the positions. I just give them an initial momentum, basically, an initial velocity, and then they just do their own thing after that. Seen some pretty interesting formations. Anyway, talk to you later.